Hello everyone, welcome to my ELP project. My name is Sarthak Jain and my topic is operational amplifier. Operational amplifier is an active circuit element designed to perform mathematical operations like addition, subtraction, multiplication, etc. The key points of operational amplifier are amongst the most widely used building blocks in the electronic circuits. An ideal operational amplifier would have infinite voltage gain, infinite input resistance, and zero output resistance. Real operation amplifier have several non-ideal characteristics. However, if we choose the components appropriately, this should not affect the operation of our circuits. The history of operation amplifier are, it was invented by Carl D. Schwarzschild Jr. In 1941, it was made into production for the very first time. Uh, the diagram of the operational amplifier will have a triangle with two lines. One would be the inverting input and one would be the non-inverting input, and one line would be the output. The characteristics of the ideal operational amplifier are infinite voltage gain. A voltage difference at the two inputs is magnified infinitely. Infinite input impedance, no current flows into inputs. Zero output impedance, rock solid independent of load, and infinitely fast. Operational amplifier without feedback. The internal operational amplifier formula is V output is equals to gain times V positive minus V negative. If V positive is greater than V negative, then the output is positive, and if V negative is greater than V positive, then the output is negative. Infinite gain in the negative feedback. Infinite gain would be useless except in the self-regulated negative feedback regime. Imagine hooking the output to the inverting terminal. If the output is less than Vin, it shoots positive. If the output is greater than Vin, it shoots negative. Positive feedback pathology in the configuration below. If the positive input is even a slightly higher than Vin, the output goes way positive. This makes the positive terminal more positive than the Vin, making the situation worse. The system will immediately rail at the supply voltage. The golden rules of the operation amplifier are the input to the operation amplifier draw or source no current. The op-amp output will do whatever it can to make the voltage difference between the two inputs zero. Inverting amplifier example, applying the rules, the negative terminal at a virtual ground. So the current at R1 is equals to IF is equals to Vin upon R1. So the voltage drop across R2 would be IF R2 is equals to Vin times R2 by V output is equals to minus Vin R2 by R. Thus, the Vn amplify by a factor of minus R2 by R1. The negative sign earns title of the inverting amplifier. Current is drawn into the op-amp output terminal. Similarly, in the case of non-inverting amplifier, the V output is equal to V in times 1 plus R2 by R1. Thus, the gain is equal to 1 plus R2 by R1 and is positive. So, current is sourced from the op-amp output is in this example. Summing amplifier, much like the inverting amplifier, but with two input voltages. Inverting input still held at the virtual ground. So we get the inverted sum V output is equal to minus RF into V1 by R1 plus V2 by R2. So we have any number of summing inputs. Differentiating amplifier, the non-inverting input is a simple voltage divider. So by calculating, we get the V output is equal to R2 by R1 into V positive minus V negative. Therefore, the voltage difference is signified in the V output. Differentiator high pass. For a capacitance, Q is equal to CV. So I capacitance is equal to C dV by dt. So V output becomes minus RC dV by dt. In the case of V naught sin omega t, V output is equals to minus V naught RC cos omega t. Thus, the negative dependence means the higher frequencies of amplified more. Low pass filter integrator. In this, the circuit diagram is given. IF is equals to Vn by R. So C dV by dt is equals to Vn by R. So the V output comes out to be the minus 1 upon RC integral of Vn dt, and therefore we have an integrator low pass. The difference between the ideal and the practical op amp are the ideal and practical. The loop gain in ideal is infinity and in practical is 10 to the power 5. The input impedance in ideal is infinity and in practical is greater than 1 mega ohm. And the rest of the difference you can see in the slide. There are many applications of the operation amplifier and some are listed below. An inverting amplifier can be used as a trans resistance amplifier, which is also called the trans impedance amplifier. This amplifier works as a current to voltage converter used in less power based applications. The op amp maintains the equal potential of the voltages at two terminals, so it can be used in many fields. These op amp are used to mixed concept where the RF signal are present. It can be used as a phase shifter, and there are many much more applications of the op amp. In this video, we have studied everything regarding the operational amplifier, its history, its circuit diagrams, the various type of operational amplifiers, and the difference between the ideal and the real operational amplifier. And at last, we have studied some of its applications used in our daily life. So, thank you.